Part 1, Solving the problem. Before solving any linear programming problem, we need to have an objective and linear equations called constraints to solve it. Objective function is basically a profit or cost function, and our objective is to maximize the profit and minimize the cost as the case may be. So for any problem, either we will be maximizing our profits or minimizing our costs. Now, how do we know what our objective function is? It can be represented by any capital alphabet. I will be using capital Z for objective functions here. Z can be written as 4x plus 5y plus 6z, where rupees 4 is profit per unit of product x, rupees 5 is per unit profit of product y, and rupees 6 is per unit profit of product z. That is how we will be calculating our overall profit, right? Simple maths. And since it is profit we are talking about here, we will be maximizing it. So our objective function is to maximize z, that is equal to 4x plus 5y plus 6z. Coming to constraints, constraints are bottlenecks, that is the limited resources available with the enterprise. In this case, which will be the resources used to produce these products X, Y and Z. Say there are only two resources in this case, machine and labor, and the limit is that we have only 100 machine hours available and 100 labor hours available with us. And say the per unit product requirement in machine and labor hours is as follows. So our constraint equation of machine hours will be 0.5x plus 0.4y plus 0.25z is less than equal to 100, and for labor hours is 0.25x plus 0.3y plus 0.4z is less than equal to 100. Here we have used a less than equal to symbols because maximum hours available is 100. So either complete 100 hours can be utilized or less than 100 will be required. And the final constraints where we define the parameters for values of x, y and z is that x, y and z are more than equal to 0. That is, the values of x, y and z cannot be less than 0 or negative. So our problem is formed as we need to maximize z, that is 4x plus 5y plus 6z, with respect to the following conditions, and the conditions are 0.5x plus 0.4y plus 0.25z is less than equal to 100, 0.25x plus 0.3y plus 0.4z is less than equal to 100, and x, y and z are all more than or equal to 0. In a similar way, we can form a minimizing function wherein we will be provided with cost per units of productions and we will obviously like to minimize it. The constraints can be given in the following manner. Minimum number of total units to be produced is 500. So the constraints will be that x plus y plus z is more than equal to 500. Here, more than equal to 500 is used as a minimum requirement is mentioned in this case. But in the previous case, we had maximum hours available and we had a constraint over that. Thus, we had used less than equal to there. Minimum requirement of product Y is 200 units. So, Y is more than equal to 200. Units of product X have to be equal to or greater than the units of product Z. So here, this can be written as X is more than equal to Z, or X minus Z is more than equal to 0. There can be numerous constraints. For better grasp, I would prefer the readers to practice problem formulation before moving forward. Pick up the practice manuals and try to solve problems formulating questions.